Today, we are going to go over or review, I should say, how to solve literal equations. We spent some time with that in the first marking period, and that oftentimes is something that confuses students. We tried to introduce it with shapes, but that seemed to be a bit of a confusion as well. So, we're going to take today, I'm going to take a couple of minutes and refresh you what a literal equation is and how we are going to solve it. So this is going to be the literal equations review in Schoology. Go ahead and navigate to that, pull up those notes, and I will share my screen so we can go to the notes, go through the notes together. All right. So let's first begin with the definition. A literal equation is an equation that has more than one variable, more than one variable. More than one variable. Some examples of literal equations are some things you've probably seen before. One that you will see a lot here soon, y equals mx plus b. If you aren't familiar with that, you will be. Another one is a equals length times width. This is the formula for the area of a rectangle. Oftentimes you'll see formulas as literal equations. That's typically what they are. Area is one that you'll see. This is the area for a rectangle. The area for a triangle is going to be a equals 1/2 base times the height of a triangle. This is something you've seen before in your earlier years in your math classes. All these different things, all these formulas are literal equations. All right. So it's not something that's completely brand new. We're just manipulating them now. And that's the part that may be a little confusing. So to solve literal equations, our first step, our step number one, is our goal is going to be to isolate, which means to get by itself. Oops, wrong editor there. If you guys do that, remember you can switch between the text editor and the equation editor. One says text box, one says equation. You have to be in the equation one to get the math symbols and in the text box to get text. So back to what I was saying, to solve a literal equation, we have to isolate, and to isolate means to get by itself. We have to isolate the variable we are trying to solve for by using our inverse, which means opposite, our inverse operations. For these, one of the things I think that confused students is that they were looking for a number, but when we are solving literal equations, there is no numerical value. There is no number. So you will not get a numerical value. You will not get a number as your answer. You may have numbers in it, but the number will not be your answer. So I'm going to go through a few of these. I'm not going to go through all of them because you will start to get the example for how these are done after a little bit of time. So let's look at number one. Number one says solve the equation for A. So since we're solving for A, uh, we need to get A by itself. How are we going to get A by itself? To get A by itself, we need to move that B over. How are we going to move that B over? By performing our inverse operations. So our goal is to get A by itself. And the way we're going to do that is to perform our inverse operations. So this one is pretty simple. We just need to subtract B on both sides. Minus B, minus B. And what we have after we do that is going to be A equals C minus B. All right, that one wasn't too bad. In fact, it was pretty easy, don't you think? So now let's look at number two. Number 2 says, solve the equation for x. So I need to get x by itself. Let me change colors. I need to get x by itself, right? X needs to be the only thing on this side. So for that to happen, I need to move this w and this y over. So first I'm going to move this w by performing my inverse operation. There's a subtraction happening here. So I'm going to add plus w to both sides, plus w to both sides. W goes away on this side. And then what we have is going to be xy is equal to z minus w. The process for solving these literal equations is exactly the same actually as solving regular equations with numbers and all that kind of stuff, or if you just have one variable as opposed to more than one. So now I still don't have this x by itself. It's next to this w. What's happening between this x and this y? These two things are being multiplied. We see that they are right next to each other. They are smooshed together. Since they are right next to each other, that tells us that multiplication is happening. And to undo that, to do the inverse operation, the opposite of multiplication is going to be division. So I'm going to divide both sides by y. And once I do that, this y divided by y goes to 1. I have 1x on this side, but I'm not going to write that 1. So I have x is equal to z minus w. And I got to put these in parentheses for Cami, or it won't type it out right. Z minus w over y. All right. Number 3, I'm not going to go through that completely, but I will help you get started in the right direction. This is asking us to solve for w. We need to get w entirely by itself. How are we going to get w by itself? What's happening with L, W, and H? You should be able to figure that one out. If you can't, send a message to me, ask for help, and I'll help you. Let's look at number 4. Number 4 says solve for H. H is what we're solving for. This bit right here is what we're trying to get by itself. This one looks a little different because it has a number in it, but we're going to still do the same thing. We are going to perform our inverse operation. So what's happening with these things? All these things are being multiplied together. So we need to divide to get rid of them. We have 1/2 b times h. So first I'm going to multiply by 2. The inverse of 1/2 is 2. So I'm going to multiply by 2 on this side and on this side. And I have 2a. 2a is equal to b times h. Now, if you see that you can just divide by both at the same time, then by all means go ahead and do that. But instead, I like to go step by step to make sure I don't make any mistakes, which is why I multiply by 2 first. And now that I see that this b is being multiplied to this h, so I'm going to divide both sides by b. Now that I do that, I have this 2 over a, 2 times a, 2 times a over b is equal to h. Now this problem should look familiar. I hope it looks familiar. We've had it in some past classwork, so that one should be a little bit familiar. All right, I am going to do number 6. I'll get you started on y the same way I did with number 3. We're solving, started with number 5 the same way I did for number 3. We're solving for y in this one. We are solving for y. And so what are we going to do to get y by itself? To get y all by itself, all right? If you're confused on that one, stay tuned. Number 6 is going to be a very similar way. So we are solving for x in number 6. Solving for x in number 6. We're trying to get that one by itself. So my first step, I see that there's some subtraction going on. Anytime we have these multi-step problems, literal equations, we want to undo our addition or subtraction first before we undo our uh, multiplication or division. So my first step when solving literal equations is going to be to undo my addition or subtraction. If I don't have any like terms to combine or any distribution, I'm going to undo my addition or subtraction first, and then I'm going to move on to the multiplication, undoing the multiplication or division. So here I'm going to add 2y to both sides, plus 2y plus 2y, since that's the opposite of minus 2y. And now I end up with this ex is equal to 3z plus 2y. And now I have this e times this x. I'm solving for x. And I see that e is being multiplied to that x. And I know that because those two are smooshed right up next to each other, that indicates multiplication. And to do that inverse operation, I am going to divide by e. Divide by e. All right. Now that I've done that, I end up with x is equal to, and I'm going to need to put this in parentheses because Cami doesn't like it if I don't do it that way. To make it look right, I have to do it. 3z plus 2y all over that e, okay? So that's what we're going to do. Now let's look at, I'm going to skip 7 because 7 is very similar to 6. 5, 6, and 7 are all similar. I'm going to go on to 8. 8 says fuel economy. A car's fuel economy, E, miles per gallon, is given by the formula E equals M over G, where M is the number of miles driven and G is the gallons of fuel used. Excuse me. Solve the formula for M. So it's given us the formula. It's given us E equals M over G. E equals M over, oops, I'm not even typing. E equals M over G. I don't know how I did that. That's not right at all. Oh, it's not uppercase. E equals M over G. There we go. And we are solving this thing for M. Solving for M. What's going on between this M and this G? Those two things are being divided. So to do that inverse operation, I'm going to multiply by G on both sides. Times G, and what I have is going to be this G E is equal to M. All right. The 3 I didn't do, you should be able to do on your own. If you can't, by all means, ask a question. I want you all to do well on this stuff. So yes, ask questions. Please send a message if you have to. Rewind the video, go back through all that kind of stuff. Whatever it takes for you to grasp the material. All right. Make sure you do the classwork and the exit ticket after this. All right.